Hi, we're continuing our financial section, moving on to section 4B. Roman number 1 is compounding interest. A couple of definitions that we need to know before we move on are principal, simple interest, and compound interest. Principal is the balance on which your interest is paid. This can change according to what time frame you're looking at. So do you want your principal to be at the very beginning of when you invested, or maybe it's a couple of years down the road and you want to start afresh? And so the principal is the interest, or is the balance in which you pay on your interest. Simple interest. This is interest only paid on the original principal. Compound interest is the interest paid on the original principal plus any accrued interest until that next point. Bonds are always done in simple interest. So if I bought a bond at $1,000 with a coupon rate of 10%, the coupon rate would be the APR per se, and it's always done in a simple interest. How much will you receive after a 5-year maturity date? So I know the answer's there, but I'm going to walk through it with us. So if I start at $1,000, and simple interest means that I have interest only being paid on the original principal. So I have 10% of the original principal. 10%, move the decimal over 2 is 0.1. I can either use my calculator or use Microsoft Excel, or you can just move your decimal over 1, 2, 3 zeros, so 3 decimal places gives you, move it over 1, 2, 3, $100. Now this is for every year because it is simple interest and I have 5 years for the maturity date. So times that by 5 years equals a total of $500 in interest over the entire, I'm going to highlight that, over the entire bond. Now let's talk a little bit about compound interest. This is where it gets interesting. Compound interest is the interest paid on the original principal or balance plus any accrued interest. So our first formula is A equals P times the quantity 1 plus APR raised to the Y. Now this one is only used for annual interest, so only in 1 year. So A is going to stand for amount final, and that's how I think of it in my head. Amount final. P stands for, I'm guessing you already know, is principal. APR is the annual percentage rate, and Y is the number of years. Okay, so if I want to find, and we're going to go ahead and do it 2 different ways to compare simple interest and a compound interest. Now this is just when it's compounded annually, so I get a compound every year. And there's different compounds. There can be monthly, bi-monthly, quarterly, trimesterly, semesterly, although that would be called biannually, or semi-annually. Biannually would be every 2 years. Okay, so we're going to go ahead and compare simple interest versus compound interest. So I invest $100 into 2 different accounts. The first account is simple interest, 10% a year. That means I only get 10% of the original investment. The next one is compound interest of 10% a year, and this is the original plus any accrued interest. What is the balance after 5 years? So with simple interest, we're going to do like we did before. I know the answer's there, but I'm going to go ahead and go through it with you. If I have $100, the simple interest is only on that $100, and it's 10%, so 0.1, equals, move your decimal over, I have 2 zeros here, so move it over once gives me a 1, move it over again, I have 10. And that's for 5 years, so I need to multiply that by 5, will give me the interest of $50. So my total balance is my original, equals my original $100 plus the $50 in interest will give me $150 at the end of 5 years. And I'm going to go ahead and highlight that. And I'm going to get rid of this so that my pages all still line up at the end. Okay, let's go ahead and look at the compound interest now. Compound interest means I'm getting 10% of the original plus the accrued interest. So the first year, I get 10% of 100, just like we did before, and I only get $10 that first year, just like the simple interest. But now that $10 is added into my account, and my new principal for the next year is $110. So that $110, I get 10% of that. Move the decimal over 2 places, I get 11. Now I add that back to the balance, and now I have $121. 10% of this is 12.1. Add that back in, 12.1 plus 121 gives me a new balance of $133.10. Okay, 10% of that, move your decimal over, and I get 13.3. 13.3 plus $133.10 gives me $146.41. Okay, so we have year 1, 2, 3, here's year 4, so I have one more year to go. Year 5, so I have 10% of $144.41 gives me $14.64. Now that's what I accrued in interest in the 5th year, so I need to add that back in for my total for the 5th year, and I have $146.41 plus $14.64 gives me $161.05. Now I really like Excel for this, and of course you're going to be doing some Excel projects, so I think it's good to get in and get familiar with it. So let's look at this really quickly so I don't have to come back. 10% interest, 5 years. Okay, so we'll come in here. I'm starting with $100, and just for my sake I'm going to write 10% up here so I don't forget, and let's go ahead and figure it out. So I'm going to earn interest of 10% on my original, my principal, and I'm going to times that by 10%. Now I could type in 10%, but just for something different, I'm going to come up here and reference 10%. And it's always 10%, so I want that to be an absolute cell reference. So I'm going to press F4 after I do that cell. Now some people have a problem with their F4 and they might have to press like function F4 to get it to work. If it's not working for your keyboard, that's fine. All you need to do is type a $sign that says I'm absolute referencing the column and then an absolute reference of the row. So I need a $sign before the column and a $sign before the row, and that absolute cell references just D1, which is where you find the 10%. Pressing enter gives me $10 just like before. Now in this one I want to add the 2 previous. I could go ahead and put cell reference C2 and then add and then left click here and it will add those, or I can use a built-in Excel function which is sum, and it says add everything that I'm highlighting. You can close it off or just press enter. Excel will acknowledge both. And what I've done for that, just in case you're new to Excel, is when I type in sum, do it again, I type in sum, shift, parenthesis, then I come over to my cell, I left click and hold the click, move over, and then release, and those are all the cells that I want to add. Press enter. Now my new balance is this 110. Again, I'm going to cell reference, just a left click, that's the new balance. And again, I want 10%. But notice when I did my equation for this one, I did an absolute cell reference C2. So if I get my crosshairs down here, my little plus sign, and drag it down with a left click and pull, it will change. Now what I've done is I've said, because I didn't absolute cell reference the C2, when I drag it down, it will reference the next one that I pulled it down to. So now I have the C3, but I did absolute cell reference the D1, so that one stayed the same, which is good because it's a 10% the whole time. This one I didn't absolute cell reference anything. It just says add up the two cells to the left. So if I get my crosshairs and drag it down once, it'll absolute cell reference the two cells to the left. Now I have all three of these cells working perfectly. I'm going to get my crosshairs and bring them down 1, 2, 3, 3 years, 4 years, 5 years. There's my total after 5 years. Pretty slick. Again, I'm going to kind of go through that really quickly. The reason I didn't just highlight this row and take it down, some of you are thinking, well, you had all three. Why didn't you just move? This over here was different. I had to absolute cell reference the new total. This one I had to type in because we started with 100. So again, I had to bring this down and therefore bring this one down and then bring this one down so I could reference all three of those and then bring it all the way down to my 5 years. Let's go check. $161.05. It was the same. So Microsoft Excel can really speed things up for you, especially on your homework supplements. Let's move on. So here is our you could also use your compound interest formula, which we gave to you up here. A equals P times the quantity 1 plus APR raised to the y. So here's our compound interest formula when it's annually, and this one was compounded annually. So I have the principal was 100, bring down the 1, it's the same. APR, change it to a percent or to a decimal, it was 10%, which is 0.1, and 5 years. Now you could do this in your calculator or you can do this in Excel. In fact, some of you might not be sure how to type that into Word. So I'm going to do it in Word just to show you one more time. I know we've done it a bunch of times, but I'm going to assume that not everyone started on the first lecture. So I'm going to come up here to equation, press equation. Oh, it's not coming up. I don't want one of those. I want an equation. I think it's not reading it because I already have an equation there. There we go. I'm going to come paste it down here. Okay, so there's my equation. That shouldn't be a problem to you because yours probably doesn't have an equation previously. So here is how we type it in so that you can do things in your homework. Just start typing capital A equals, now I need my principal, and I'm going to go ahead and do it like I'm typing it in. I can put times or I can leave it. When we're writing things out, you don't have to put a time sign in. But if you're going to copy and paste this into Microsoft Excel, which I'm going to show you to do, it has to have a time sign because Microsoft doesn't acknowledge a blank spot. There's too many operations in Excel, so I do have to put a time sign to tell it what to do. 1 plus 0.1. Oops. I'm going to highlight all of this because I want that being raised to a power. Come out to my power, and that was 5 years. Now I'm going to highlight just this portion, copy, come into Microsoft Excel. This will kind of help speed you up on your homework supplements. Press an equal sign because I want it to calculate like a calculator. I'm going to paste this in, Control V. Now notice Microsoft Excel says I don't understand what this is. It doesn't understand brackets. It does a combination of a bunch of parentheses. So I'm going to get rid of these and put a parenthesis set instead. It does say need to multiply. Actually, let's just get rid of those parentheses because I already have the multiplication sign in there. Now, I'm going to double check because Microsoft Excel is kind of finicky. So I have 100, I have a time sign. If I don't, it won't calculate it. Parenthesis, for my order of operations, 1 plus 0.1, good. All of that being raised to the 5, There we go. And it matches 161.05. So we have lots of different ways to figure out the answer. I'm going to delete this one so that all of my notes still end up lining up at the end in the pages. Okay, let's move to the next one. And I don't need two A's in there. Okay, so here is my answer. I need to highlight that so that you remember to highlight your answers when you turn in your homework supplements. Any way works, some way to set it apart. Bold, different font, highlight, some way. You could even circle it by inserting shape and doing a squiggle in a different color. Come up here and say this is it, and then change the color, or even just leave it. Okay, moving on. Compound is exponential growth. New College has a debt, and it shows in this example just how money grows so quickly, either in debt or in an investment. In this case, New College has the values of its debt rise for 100 years. Let's just assume that it's starting out at $224, which isn't a lot of money, and it has an interest rate of 4% a year. Not too bad. So here is our visual, this graph. Notice it really stays low for quite a while, and then after 50 years it kind of gets a little higher. The next 50 years, notice how much it jumps. I would say we're maybe at $1,000 here. From there, clear up to past 10,000. In fact, it tells us at 100, it's $11,313 after 100 years, and it only started out with 224. That's kind of a testament as to credit cards and debt of your own. If it's an investment, that would be fantastic. But it does grow very slowly at first, and then after that it just takes off. Okay, we're going to do a simple interest here with New College and just kind of compare the two of simple interest versus compound interest. Okay, so our simple interest, it was 4% a year. Oh, that's what we were assuming. We're going to do it a little differently and just do 2%. So if I started out with $224, and let's do 535 years, just because, and an interest of 2%. I know it's not the same example as the picture, but we're just going to compare the two of simple interest versus compound interest. So simple interest means I'm only paying 2% on the original principal, which is $224. 0.02 times $224 is only $4.48, not even $5 per year. Now, I have 535 years, and I have $4.48, so I times those together. That should be a decimal. And to show you that we can hurry and do this in Excel, I'm just going to copy so you don't have to go to your calculator every time you want to calculate something. Paste. There you go. $2,396.80. Yep, it matches. That's what I had. But you still have your original principal. So I add $224. And at the end of 535 years, I'm only at $2,620. Really not that bad after, 5,000 years. And I've circled this one. You can highlight it in any fashion to say this is my answer, just so that I can tell it apart. Okay, compound interest means that I'm adding interest from the principal and any accrued interest, which is convenient when you're making an investment, not so much when it's a debt. So again, we're going to use the same as before, 535 years, the principal of $224, and an interest of 2%, just to compare what happens. Now I have my formula that was given to us earlier, A equals P times parenthesis 1 plus APR, all raised to the Y. So let's just plug it in. $224, and you can, once you have it typed in once, and you can just copy and paste it down for your next one and insert what you need. In fact, I'm going to show you. Copy, bring it down here, paste. There you go. And because it's two separate things, I'm going to put some spaces. My interest is 200, or my principal is $224. The APR is 2%, so 0.02. And it was for 535 years. Kind of nice. Now I'm going to get rid of that because I want everything to line up again. Okay, so now that we have all that, we can type or copy and paste that into Microsoft Excel, so you don't have to go through and type it into your calculator again. That's up to you though. And if I want it to work like a calculator, remember, put an equal sign, Control Paste, or Control V. Now remember, Microsoft Excel will not recognize this as a multiplication, even though we know that. So we have to type in a multiply, which you can find on your number pad, or Shift 8. Everything else looks good, and you use your caret for raising something for a power. Press Enter. Ooh, let's go ahead and format that as currency, and then let's copy and paste this in for my answer. And I already have that there, but just so you can see, kind of speeds up your homework to use Excel. And there's your answer. I'm going to delete it because I already have the answer there. So after 535 years, let's go back to comparing these. In the simple interest, it's only a mere $2,000 versus compound interest, $8,940,049.24. A little different between compound and simple. Let's move on to another example. This one's the mattress investment. So let's say 50 years ago, your grandpa didn't trust the banks. Or I guess some of you might be older. We could say father, or you could just think years ago. Your grandpa didn't trust the banks, so he hid his life savings of $100 under his mattress. His competitive neighbor invested the same amount in a bank with an APR of 3.5 compounded yearly, which is really equivalent to the inflation. So it's not really an investment, although it is compared to what your grandpa did. So we're assuming that nothing happened to the bank, which nowadays doesn't happen as often. And let's compare the two investments. So because this is compounded yearly, we're going to use our compound interest formula, which we gave you previously. And by the way, I don't like this one because I'd rather only give you one equation instead of two, and your book gives you two. So if you don't want to memorize two, I'll give you a second equation in just a little bit. But for our purposes to kind of work us into the next one, this one's a simple equation. So I can just copy and paste once I have it written up with my equation writer. And for your homework supplement, you can just start taking out these numbers and putting in what you have. So it was a compounded yearly. So my principal, he started with $100. So I'll type that in. The APR was 3.5, so move the decimal over 2 to get 0.035. And the years, I think it said he was 50 years ago, 50 years. So now that I've typed it in here, I can go ahead and copy and paste this into Microsoft Excel, have it calculate for me, equals Control V. But remember, Excel will not acknowledge that without a time sign. There we go. And I can format this, format cell into currency, and there's my answer. So I can copy and paste my answer straight back in, or you can go ahead and use your calculator, it doesn't matter, which I've already done, $558.49. Again, highlight it in some fashion and maybe make them all consistent. I'm making mine all different because each of you are going to pick something different. And your grandpa's investment, it's still the $100 that he shoved under his mattress, and therefore the competitive neighbor did better in this case. Okay, Roman numeral 4, compound interest paid more than 1 year. This is the equation that I'd like to give you from the beginning, but we're working you into it. Now that you know, you don't have to memorize this equation. You could use the next one for all of your problems, and it's up to you. So compound interest paid more than once a year. that means that it's compounding more than just once every year. So I'm adding interest upon the original principal plus any accrued interest, and if it's compounding in more than once in a year, in these problems, I'm going to be compounding throughout the year, not just once a year, and adding that interest and accruing even more interest than the simple interest or even the annually compounding interest. We'll do a couple of examples to help that make sense. So you have a bank that has an APR of 8% and it's paid at the end of every year with a principal of $1,000 will result in, just at the end of 1 year, $1,000 times its 8% is $80 in interest, and your total will be $1,080, right? But if you take that same 8% and compound it quarterly, that means 4 times a year, you get, divided by 4 because it's 4 times a year, you're going to get 2% every 3 months. So in the first 3 months, you're going to get a little 2%. In the next 3 months, you're going to get a little 2% of what you originally invested, the original principal, plus a little 2% that you got in the first quarter. Then 3 months later, you're going to get another 2% that happens upon what you invested originally, plus the little bit of 2% that you got in the first quarter, the second quarter, and now this third quarter. And same until the end of the year, which is when you're going to get from an interest from the original, the little 2%, the other 2%, and the other 2%, and now you're going to get 2% of all that you accrued. That is the compound interest, paid more than once a year. So here's our new formula. Because I'm getting a little bit every couple of months, that's why I have my APR divided by the number of compounds. And that's where this new part of the formula comes in. I get a little bit at every single point in the year and not just once. So I take my APR and I divide it by n. And so I get a little bit. I know some of you are thinking, but that's a lesser number, but you're getting it more often, which makes a big difference. And up here, the n and the y are still, n stands for the number of periods that you're going to be compounding. So if it's quarterly, n is going to be 4 because it's compounded 4 times a year. And up here, you get it 4 times the number of years. So that's why it makes up for it. So you're getting it divided, but then you're getting it a lot more frequently. So I get n times y. So let's take, actually I don't want to do that next example. I want to do something different that I wasn't planning on. Let's compare this $1,000 if you just got it once, and let's do it saying you got it that 4 times a year. So I want to, now that I have this in here, I can copy and paste, but for the purpose of showing you how to do an equation, I'm going to go ahead and do another one. So you insert equation. I'm going to just do capital A equals, and I'm going to type in what my what everything is. So I have $1,000 parenthesis times quantity 1 plus, I need a fraction, so I'll come up here and insert a fraction. My APR was 8.08. Whoops. And I get a portion of that, which is quarterly, so divided by 4. Close off my parentheses. And now I need to raise all of this. So I'm going to highlight what I want raised. Design tools, up here I want a superscript, which is a power. Raise that to n times y. N is the number of periods, or 4, because it's quarterly. And I'm going to type in a times sign. You don't have to, but I kind of like to keep the n and the y separate because you're going to have them together. You don't want it to say 4 and think that it's 41 and not 4 times 1, because this was for 1 year. All right, now I can type that into my calculator like before, but I'm going to highlight this and put it into Microsoft Excel. Make it work like a calculator by putting an equal sign. Notice it has these weird brackets again. I'm going to get rid of those. And I need to put a times sign because it doesn't recognize a blank. And just make sure I have everything. These are inside a parenthesis. 0.08 over 4. Okay, there we go. So I'm going to format my cell to be currency and then copy and paste it in for my answer. And I get $1,082.43 versus just the original interest, which was compounding just once a year. So in this case, I got $2.43 more. And you're thinking that's not a lot. But remember the example of the new college? It doesn't grow very much at the beginning, but the longer you keep it in, that's a big, very significant difference between the two, especially if I keep it longer and longer. $2.43. Okay, let's move on to the next one, just so you can get familiar with the new compound formula. So I invest $5,000 into an account compounded monthly with a 3% APR for 5 years. What will the balance be after after 5 years? And I have two questions. Again, just like we did up here, where I have the interest compounded annually versus quarterly. And in this one, we're going to compound it once a year. You can use the original compound formula. However, I don't really like that one. I like using this one. And if you want to compound it annually, you just make N1 because it happens once a year, and then you really only have one equation to memorize. It's up to you though. So we're going to compound it monthly for 5 years, or compound it once annually for 5 years and compare the difference. So I like the new formula since you only have one to remember. And now that you've seen how we type this in, I'm just going to copy and paste this because you already have it. And now I can type in the principal. I started with $5,000 and then APR was 3%, so 0.03 by moving the decimal over. And this one, we're compounding it monthly. There are 12 months in a year, so I put a 12. Number of periods up here will be 12 times the number of years. Delete and put 5. And then you can copy and paste this into Microsoft Excel. Equals, Control V, make sure you put a multiplication sign there, and we get $5,808, which is what I have copied and pasted into here. So now let's go ahead and do the same thing, but only once a year. And in this case, since I already have that in Microsoft Excel, I can come in here and change the N instead of being monthly to 1 in both places, when I divide by 1 and when I raise it, which gives me, and go ahead and format the cell to be currency, and it gives me my answer, $5,796. Let's go check. Yep, there we go. I've already copied and pasted it in here. You can go ahead and use the annual compounding. That's fine. However, I'd really only like to memorize this equation. And so it still gave us the same answer. And let's compare these. Whoops. Compare these two answers. Compounding monthly versus annually made a difference of, actually, let's go find the difference. Let's copy this, bring it into Microsoft Excel, and paste it in here. Those number signs say that my cell isn't big enough, so expand it. And let's find that difference. Equals my compounding monthly minus my next compounding gives me $11.71. A difference when it's compounded monthly versus once a year. So we earn even more money, even though the APR stayed just the same, everything was exactly the same. All that happened is that I got a little bit every month versus only getting the 3% at the end of the year. So you can see how this can make a big difference in the long run. Okay, let's move on to Roman numeral 5. This is annual percentage yield, abbreviated APY. You see this on commercials and car advertisements and different things. What is APY? This is the actual percentage in which your balance increases in 1 year. You'll notice up here when we had the APR be the same, the APR was 3% in both of these. But the final at the end was a little bit higher when it was compounded more. The APY that we're talking about is the percent that your balance changes in 1 year. So in this case, the APR was the same, but the balance was different. The APY would be different in these as well, because it's the actual percent that your balance increases in 1 year. So your APY will be the exact same as your APR if it's compounded annually. So the ones that we used our original formula for, this one, how much it increases in 1 year is the exact same as how much it increases, the exact same as the APR, the annual percentage rate. Okay, so, but the APY will be larger if the APR is compounded more than once a year, which we kind of anticipate looking at this, knowing that I get more money when it's compounded monthly. Because if it were the exact same, you wouldn't have as much. So it's larger. So this is the relative increase, which is the absolute increase over your starting principal. Do you notice anything? Absolute increase. Absolute meaning you take something, the new minus the old, divided by the old. Do you remember that from 4A? Yeah, it's the exact same as relative change. Change meaning that I took one item and it's moving and progressing. So, oh, by the way, there are other ways that you can find it. These are the other ones you'll find on your test formula sheet. Don't let it confuse you. It's the exact same thing. You can use the absolute increase divided by the starting principal, and that'll give you your relative increase. Relative meaning, what do you remember? Relative means percent. It should automatically come into your mind. Relative is a percent, which APY is. So you can, if you don't want to have to go through the whole process of finding the ending value, subtracting it from the original principal for the absolute increase, which is finding the final amount or the new minus the old, which would be your principal, you can just plug in your APR divided by the number of compounds a year, raised to that, subtract 1. Or you can do this one, which is the final amount, which you would still either have to find or be given, divided by the principal, raised to 1 over y, which is a fractional exponent, minus 1, or probably your new favorite, Microsoft Excel, where you can type in effect. By the way, you can find these on page 219 in your textbook, Pearson's Mathematical Tools for the Real World. And this is the page number for the BYU Idaho Custom Edition. I believe it'll be the same also if you use the original text, which has a couple extra chapters in it that we just don't go over. Okay, so I can type in effect, and then it'll prompt you to say what is the APR of the problem you're working with, and then it'll want n, or the number of compounds. And this one, you'll use the effective yield for when you know the APR, but you want to find the APY, and it'll give you the APY. Now, a couple of your problems will ask you what's the APR, and they'll give you the APY. Now, you can do this by hand, like up here, or again, you can type it into Excel, and this one you'll type in nominal yield, or nominal, and it'll ask you for the APY and the number of compounds, and it'll give you the APR. So lots of different ways you can work on these. I'm going to go ahead and stick with these ones up here for now, and I might show you a couple at the same time. Let's move on to our first example. If I have a principal of $1,000, an APR of 8%, and it's compounded monthly, let's find the APY. So I want to use this one, which would be relative increase or the absolute increase over the starting principal, which means I need the new minus the old. Remember that one? Let's type it new minus old divided by the old. Well, I have to find the new one then. So let's come down here. To find the new one, I'm going to use my compound interest formula. If I start out with $1,000, I'll put in 1,000 for the P, which I've done here. The APR is 0.08. Compounded monthly is over 12. To the N, that should be Y. NY, the N is the number of periods in a year, which is 12. And I want the APY, which means I only want 1 year. How much has it increased in 1 year? And so my final, or my total, is typing this into your calculator, or you can copy and paste in Excel. Since we've done that so many times now, I'm just going to go ahead and move on. And it gives me $1,083. Now, to find the APY, remember it's new minus old over old. I started with $1,000, I ended with $1,083, so my absolute increase is $83. So the APY is $83 over the starting principal, which was 1,000, gives me 8.3. Now 8.3 compared to my APR, here's my APR of 8%, it's a little bigger because it was compounded a little bit throughout the year. Remember that up here? The APY will be larger than the APR if it's compounded more than once. Even if it happens every 6 months, it's going to be just a little bit more. If it's only once a year, then it's going to be the exact same. Okay, now we have our other ways of doing it. We have what you'll find on your test formula sheet, the 1 plus APR over n to the n minus 1. You also have this one on your test formula sheet. You can use that one as well. And we're going to do Excel just to show you as well. So the first one, 1 plus APR over n to the n. The APR was 8%, 12 times a year, compounded 12 times a year minus 1. We can copy and paste this. Copy, go to Excel, press equals and paste. Make sure everything's in here so that it can calculate it. You know what? Just to make sure, I'm going to put all of this in an extra set of parentheses, so all of that subtracts 1. I think it's overkill, but just making sure, is 0.083, which, changing it to a decimal or a percent, is 8.3. Same difference. And the other one, A over P. Now we just found A of $1,083 over P, which is 1,000. It started at 1,000. 1 over Y, we have 1 year. So if you have several years, that one might be more beneficial. So if it's after 5 years, it'll average it over 5 years, minus 1. And this one, remember, a caret sign is a raising to a power. Let's go ahead and take this whole thing, copy and paste it into Excel. Equals, type it in. I think everything's ready to go. It doesn't have any, has a little bit of an issue. Get rid of that. And same thing, 8%, 8.3%. Now, which one do we use in Excel? Effective yield or nominal yield? I want to know, find the APY or find the APR. This one is finding the APY, so I'm going to use the effective. So come into Excel, write or type in equals and do effect and parenthesis. It's asking for the nominal rate or the APR, which was, let's go find it, 8%. So I type in 0.08, comma, how many times per year? I believe this one was monthly, close parentheses, and we still get 8.3%, which is there. So you have lots of different ways to find it, and you can use whichever one you prefer, or whichever one works better for the problem that you're working on. Let's move to the next one, daily compounding. So let's find out the APY here. So I have, the exact same problem, but I'm going to change the N to 365 days a year and see what happens to my APY. 365 days a year, so I could just copy and paste this because it's the exact same thing and just change the N. To find the answer, type it into your calculator or copy and paste it into Excel. This is a different one, so I'm going to leave some space. Copy and paste, Control V. Make sure you put a multiplication sign or it won't calculate it. Press enter. $1,083.28, which is what I have. So that's good after compounding it every single day. And that means that I increased $83.28 because I started at 1,000. So that's my absolute increase. Or to find the relative increase, new minus old over old. So I have the absolute increase divided by my principal, which was 1,000. In this case, I can just move my decimal over and I get 8.328%. So if I compound it daily, it increases my APY even just a little bit more. So I get 8.328. So just a little bit more. So what's better than monthly compounding? Weekly compounding? Better than that? Daily compounding? Sure. What about hourly compounding? We could figure out that. How about minutely compounding? We could figure out that. We know how to do unit conversions. How about every second? That would make my APY even bigger. How about fractions of seconds? Or even fractions of that? That leads us to continuous compounding. That means that it just happens all the time. It just keeps going. And that's when we get into our new formula that uses a totally new number called the natural number, E, because there's no way to type in all of these numbers. It just happens. So I have A equals, or the final amount final, times the principal, or equals the principal times E, or the natural number, being raised to the APR times Y. Now some of you may have already learned this before, but you learned it in a slightly different format. You may have heard the formula PERT. The only problem I find with telling people to use PERT is they forget to put the A out front, and they end up doing P equals E to the RT, and that's wrong. So if you think of PERT, and that's fine, just say in your head A PERT, so that you don't forget that it's A equals PERT. And E is the natural number. Here is the natural number, 2.71828, and so on and so forth. It's just like pi, except pi was discovered in geometry. The ratio of the circumference of a circle divided by the diameter of the circle. Well, they discovered E, or the natural number, just like pi, except not in geometry, but in finances and logarithms. The first reference to the natural number was by John Napier, who ends up getting a lot of credit for it, but he didn't actually have the digits themselves. Jacob Bernoulli also tried to find it, and he was trying to calculate it, but the person who gets most credit is Leonard Euler because it's named after him with the E. And you can use this on your calculator. You can find the E with the little caret, the raise to button, or you can also continue to use Excel. But Excel doesn't recognize E. You have to type in EXP and then put parentheses, and whatever you're raising the E to, that's what you put inside the parentheses. So if you were to type in E to the 3 on your calculator, you would just find your little E button and type in your exponent. Or in Excel, you would type EXP parenthesis 3 because that's the exponent, and close parenthesis. So let's move on to our first example. Let's go ahead and compound this continually. Compounded continuously. All right, so we're going to use our new formula. You can think of it as either way, whichever way helps you memorize it. A PERT, or A equals P times E to the APR times Y. Same thing. APR is R, or the rate. Y is years, T is time, same difference. So I'm going to copy and paste one of these. I can copy this one, paste it down here. My starting principal is 100. We know that nothing in between the number and the variable, or the coefficient in the variable, is going to be times, but Excel won't if you wanted to use Excel. So put your times sign if you want to copy and paste. Raise it. Actually, let's go and type it in later because Excel isn't going to read the E either. To the 0.08 for the rate. Y is years, so 10, because we were given 10 years, and it's compounded continuously, so we know that this is the right formula. I can type this into my calculator or go into Microsoft Excel. We can go ahead and copy and paste that, but we are going to do some modifications. Equals, Control V, it's not going to register the E, so I'm going to take that out and put times, because it needs a times, and type in EXP, because that's what I need for the E being raised to a number. And I already have those in parentheses, so I'm good to go. Pressing enter gives me $222.55. To format that as currency, I can just copy and paste that back in for my answer. Copy and paste, and I've already done that. $222.55. Let's go on to the next, which is Roman numeral 4, or 7, planning ahead with compound interest. So we want to know what we start out with instead of what we end with. So let's say we need to plan for college. We have a child and we need $100,000 by 18 years old. So we invest some money into an account at 5% that is compounded once a year. How much should we start with so that we get to the full $100,000? So we can use our original formula, which I don't like. I would rather use, because then you only have to memorize one, which is the one that is compounded more than once a year. And then all you have to do is memorize this one, which is that over n, and because it's compounded once a year, you make the n1. And up in here, we're going to put n times y, same difference, but I like to only have to memorize one. And then in this one, you would just have that divided by 1 and 18 times by 1. And we're looking for the principal here. So I want my amount final to be $100,000. So I put that in for A. I don't know the principal. That's what I'm looking for. 1 plus 0.05 is the APR. Change it to a percent. And I have until they're 18 years old. Where I can use my other formula, divide it by the number of compounds. It says once a year, so it would be divide by 1. And n would still be 1 up there, which gives us the same thing. But I want to solve for p in this one. And this is p times all of that. So to isolate p, I divide both sides by 1 plus 0.05 over 18, which I show down here on the next step. P equals, it crosses out on this side because I'll have one on top and one on bottom. On this side, I'm left with 100,000 over my division of all of that. I can copy, come back in here to Excel, press equals, and make it work like a calculator. Press equals. There we go. Format it into currency. Some of you are thinking, why don't you format all those cells? I'm thinking that about now too. Let's just format all of these cells because I'm going to come in a little bit. Format them all as currency. Oops. Some of them were, so it took it off. Make them all currency. $41,552 I can copy and paste. I've already done that for us. And that's what you need to start out. So If you have a child who was just born and you have 18 years to plan for college and you want $100,000 for this college account, you must have $41,552.07 to get to that full 100,000. Sound logical? Well, if some of you have that chump change of 41,000 in your back pocket, then go ahead. But we're going to get into the next section, which is talking about how you can add in payments. This is, you just drop that lump sum in there and then let it mature for 18 years and you have your 100,000. We have those other payment plans that we'll do later. But if that's what you have, then that's what you have. So the next problem is the exact same as A, but in this case it's 7% and it's compounded monthly, not just annually, which is once a year. So we're going to take our other formula, which is the one I'd rather you just memorize anyway, and type in for n, it's going to be monthly, so 12. So we still want to have 100,000 at the end. We still don't know the principal because things are changing in this one. It's going to be a different principal. Compounding this one monthly and having a 7% APR versus 5%, so this person just find a better bank or investment, 0.07 over 12, and raising this to the 12 because it's 12 times in 1 year and it's for 18 years. Again, divide both sides by this so that p is isolated, and we know it's divide because it's p times something, and the opposite of that is dividing, and you're left with 100,000 over that mess. Again, copy and paste in here, or go ahead and type it into your calculator. It's a lot of work though, now that I've taught you the fast way. Wow, look at the difference between those two numbers. 41,000 versus 28,000. A significant difference. So if you found a better investment with a higher percent and compounding monthly versus annually, you only have to start out with $28,000. So you just lump, your chump change down to the bank of $28,000 because we always have that in our back pocket, which we're going to go into that in the next section about how you can make payments to get to the same percent or the same end value. But this is how we do it in this section. All right. At this point in this section, I would be asking in a class if there's any questions. So if you do have any questions, go ahead and email me and I will go over any part of this with you. And I would also suggest reading the section all by yourself. Other than that, we are finished. I hope you join me for your next section, section 4C.